Statistics revolves around data. So this class is broken up into three main parts: collecting data, summarizing data, and drawing conclusions from data. So what's data? Hopefully by now, you've had a chance to take a look at the course survey. So in the course survey, I asked you for things like your age, your major, how far you live from CRC. So all those things are data. Data is just information that we collect. They can be counts, they can be measurements, they can be survey responses. So in this section, we're going to talk about the different types of data. So it's going to be important to know what type of data you have, because later on, the type of data you have is going to determine what you can do with it, what type of analysis you can do with that type of data. Before we go further, let me give you an overview of where we're trying to get to. Okay, so like I said, statistics is about collecting data, summarizing data, and drawing conclusions from data. So here I have some data that I collected, right? These are some scores from my fall 19 class and some scores from my spring 20 class. Okay, and I collected data because I had made a change between fall 19 and spring 2020, and I want to know whether that change worked, whether that change helped. Okay, if you think that's not interesting, think about this in terms of scientists trying to decide whether a medicine or a vaccine works. Okay, think of this as a group of people that you give the medicine to, and then this as a group of people that you give a placebo, a fake medicine to. And you want to know whether your medicine, the medicine or vaccine works. And I want to know whether my change worked. So this is raw data, right? We collected data, whole bunch of numbers. In order to understand it, we have to do something with this data. What do? You have to summarize it somehow. So you may say, take the average. And you will be right. That is one summary that we'll talk about later on. What do you do after you get that summary? What do you do after you get that average? Well, you want to compare the two groups, right? To see whether the change worked or whether the medicine worked. But here's the hard part, okay? The students who took my class in fall 19 are different than the students who took my class in spring 20, right? There are two different groups of students. No one retook my class. So there's different groups of students. So you expect there to be a difference anyway, right? The group that took the medicine, the group that took the placebo. Two different groups of people. So there should be a difference anyway. So the big question is, when is the difference big enough for you to say that the medicine worked? And when is it small that you have to say that it could be due to the fact that these are just two different groups of people, right? That's one of the big questions we'll talk about by the end of the class. Another big idea we'll get to is something like this. Okay, so here's the headline. It says 14% of Americans have changed their mind about an issue because of something they saw on social media. 14% of Americans. It's implying 14% of all Americans. Where did they get this 14%? Who did they ask? Did they ask you? I know they didn't ask me. So 14% of Americans. If you read further in this article, they actually got this number from asking 4,000 people. How is it that they're able to confidently say in this headline, 14% of Americans, which they're implying 14% of all Americans, from asking just 4,000 people, which is a really small number compared to all Americans? Okay? Is that even possible? To be able to make a statement about everybody when you only ask a small number of people. Okay? That's one of the other big ideas we'll get to by the end of the class. Data is broken up into two main types: qualitative and quantitative. So let me start with quantitative. So the word quantitative comes from the word quantity, which means how many. So quantitative data are going to be most of the time numbers. And not most of the time, they are going to be numbers. So they're going to be numbers that either count or measure something. And because they're numbers, it's going to make sense to do math with these numbers. And what do I mean by do math? I mean things like taking an average. What are some examples of quantitative data? Well, age. What else? Height. So if I ask you your age or your height, you definitely are going to give me a number, right? Age counts how many years you've been alive. Height measures how tall you are. Okay, so those two things are that's quantitative data. The other main type of data is qualitative. So qualitative are things like, what is your major? Right, so if I ask you what is your major, you would give me a word. Right, so qualitative data are most time words that are labels or categories. Now, sometimes they can be numbers. And they can be numbers if the numbers are just being used as labels. And let me give you an example of this. Do I have any basketball fans in the class? What jersey number does Steph Curry wear? I think he wears 30. And what about LeBron James? LeBron James 23. So 30 and 23. They're numbers, but do those numbers actually count or measure anything? Like the number 30. Is that a count of something? Is that a measurement of something? I don't think so. Okay? And if that criteria doesn't help, think about the second one. Right? If I take Steph Curry's number, 30, and LeBron James's number, 23, does it make sense to do math with those two numbers? For example, does it make sense to take the average of those two numbers? So if I took the average of 30 and 23, I'm going to get a decimal, right? Which is not even a legitimate jersey number anymore, right? So if I take an average of two jersey numbers, the number that you get is not even a jersey number. It's not even a whole number. It's a decimal. So jersey numbers are an example of numbers that are just being used as labels. Because qualitative data are labels and categories, sometimes you'll see the word categorical used here. I'm going to use the word qualitative and quantitative, but sometimes if you're reading other books, you'll see the word categorical. All right, so let's take a look at example one. These are some data, and we wanted to decide whether they are qualitative or quantitative. Your best friend's name. That's definitely going to be a word, right? So it's definitely going to be qualitative. Your best friend's age. We talked about age already. Age is going to be a number. Does it count something? Yes, it counts how many years you've been alive. Right, so this is for sure going to be quantitative. Part C, the number of touchdowns in a football game. It's a number, okay? Ask yourself, does it count or measure something? Yes, here, right, it does count how many touchdowns. So this is for sure going to be quantitative. Your zip code. It's a number, right? 95823 is a zip code. It's a number. Does it count or measure something? And if that doesn't help you, take a look at the second one, right? Does it make sense to do math with zip codes? If I take two zip codes and I take the average of them, is it still a zip code? I don't think so, right? If you take two zip codes and you average them, you might not get a whole number. You might get a decimal, which is not even a legitimate zip code anymore. So zip code, because it doesn't make sense to take the average of two zip codes, this is going to be qualitative. Qualitative data is broken up into two smaller subtypes, nominal and ordinal. So these are types of qualitative data. And remember, qualitative, these are the labels and categories. Most of the time, qualitative data are words. So ordinal are going to be words that have a natural order. Right? Ordinal order. So what do I mean by natural order? I mean that these words have an order that everyone pretty much agrees upon, either from smallest to largest, largest to smallest, worst to best, best to worst. Nominal are going to be words that don't have a natural order. So these do not have a natural order. So let's take a look at some examples. Part A, the categories strongly disagree, disagree, neutral, agree, strongly agree. So do these words strongly disagree, disagree, neutral, agree, strongly agree, is there a natural order to these words? Like from worst to best, best to worst? Yes, right? Strongly disagree is like the worst. Strongly agree is the best. So these would be ordinal. Part B, the names of counties in the state. So when we talk about counties, is there a natural order to the counties in the state? Now, you might say alphabetical order. So we're not going to count alphabetical order as a natural order, because if we do, then everything could be alphabetized, which means everything will be ordinal, and there's no point in talking about nominal. So if we don't count alphabetical order, is there another natural order? Is there another order that everyone pretty much agrees upon? And the answer is no, not really, right? So when you see counties in a state, sometimes you see them ordered by population size. Sometimes you see them ordered by location, from north to south, south to north. So there's no one order that everyone agrees upon when you talk about counties of a state. So counties of a state would be nominal. Part C, I ordered a pizza with pepperoni, mushrooms, olives, onions. So I'm talking about the toppings here. Pepperoni, mushrooms, olives, onions. Is there a natural order? Is there an order that everyone agrees upon? No. Okay, so this is a nominal. Part D, I got an A in statistics, a B in biology, and C's in history and English. So to be more clear, what I'm talking about here are the grades. So letter grades A, B, C, D, F. Is there a natural order to letter grades A, B, C, D, F? From like worst to best, best to worst. Yes, right? A is like the best grade you can get, and then F is the worst grade you can get. So there is a natural order, which means this would be ordinal. Quantitative data are broken up into discrete and continuous. And remember, quantitative data are the numbers. So let me first talk about continuous. So these have to do with what are the possible values of the data. Continuous, the possible values are going to be any number in a range. And when I say any number, I mean including any decimal. All right, let's talk about an example here. Weight. So if we talk about weight, what is a possible value of weight? Well, 150 pounds, right? That's a possible value for weight. What's another possible value for weight? 180 pounds. Okay, is any decimal between 160 and 180, is that also another possible weight? For example, if we said 155.791, is that a legitimate weight? Is that a possible weight that someone could have? I forgot what I said. 170.591. Is that a possible weight? Yes, right? So any decimal between 160 and 180 is a possible weight, right? That would be an example of a continuous quantitative data. Discrete, the possible values are not going to be any decimal, right? The possible values are I'm going to say the possible values can be listed. The list could be infinite. All right, so let's talk about an example here. Okay, so if I ask you for how many followers you have on Twitter, and I should be clear here, the number of followers you have on Twitter. Okay, if I ask you the number of followers you have on Twitter, what are the possible values you could have? Well, you can say you have 0 followers, right? What's another possible value? 1, 2, 3, and so on. Okay, so I can list all of the possible followers someone could have on Twitter, right? It could be 0, 1, 2, 3, ... So that's what I mean by it could be infinite. But what's important here is that I can't have any decimal, right? So it doesn't make sense to say that I have 2.358 followers. Okay, so that's what makes it different. That's what determines the difference between continuous and discrete. So think about what are the possible values. If it can be any decimal, it's going to be continuous. And if it's not continuous, then it's going to be discrete. Let's take a look at some examples here. So all of these are going to be quantitative, so all of these should be numbers, and we're going to decide whether they are discrete or continuous. Part A, the amount of caffeine in a cup of Starbucks coffee. So caffeine is usually measured in milligrams, right? So what's a possible value for milligrams? Could it be any decimal? Does it make sense to have 100.12891 milligrams of caffeine? Does that make sense? Yes, it does. So if it makes sense to have any decimal, it's going to be continuous. Part B, the distance from a student's home to his school. So distance is usually, we're talking about miles, right? Does it make sense to have any decimal as miles? Does it make sense to have 20.87192? Is that a possible distance? Yeah. So this would be continuous. Number of steps in a stairway. Okay, number of steps in a stairway. What are the possible answers here? Right, the possible answers are just going to be whole numbers. Right, it doesn't make sense to have 2.381 steps. So this would be, because the possible values are not going to be any decimal, this would be discrete. Part D, number of students enrolled at college. So when we talk about number of students, the possible answers here are, they should be whole numbers, just whole numbers, right? So it doesn't make sense to have decimal number of students. So this is going to be discrete. The length of your foot. So when we talk about length, say inches, right? Is it possible to have a length that is any decimal? So like 8.197 inches. Does that make sense as a length of someone's foot? Yeah, right? So you can have any decimal, which means this is going to be continuous. Shoe size. What are some possible shoe sizes? Possible shoe sizes are 7, 7.5, 8, 8.5, and so on. Right? Even though you can have halves, do you ever see a shoe size that's 7.2391? You don't, right? So even though you can have some decimals, you can't have any decimal, right? When we talk about shoe sizes, let's be clear, shoe sizes in the US. When we talk about shoe sizes in the US, these are like the only possible values you have, right? Whole numbers or whole numbers and a half. So possible values are not any decimal, even though there's some decimals, but it's not going to be any decimal. So shoe sizes are not going to be continuous. They're actually going to be discrete. And this is like one of the only examples that I know of where it's discrete and it has some decimals. Most of the time, discrete is going to be just whole numbers, right? So here, number of students, just whole numbers. Number of steps, just whole numbers. All right, let's put everything together. For each data, we have to first decide whether it's qualitative or quantitative. If it's qualitative, we have to decide whether it's nominal or ordinal. If it's quantitative, we have to decide whether it's discrete or continuous. All right, so I should have 2 words for each data. Part A, number of patients who reported that a new drug had relieved their pain. It's a number, okay? So it could be quantitative, but remember, you have to ask yourself, does this number count or measure something? Yes, it does, right? It counts how many patients had their pain relieved. So this one is for sure going to be quantitative. Okay, if it's quantitative, it's going to be either discrete or continuous. And the question you should ask yourself is, what are the possible answers here for number of patients? So when we talk about number of patients, the possible answers are going to be just whole numbers, right? So in other words, you can't have decimal patients, right? So 2.358 doesn't make sense as a number of patients, which means it's going to be discrete. Part B, the MPAA rating of a movie. So G, PG, PG-13R. These are words. So for sure, they're going to be qualitative. And if it's qualitative, it's going to be either nominal or ordinal. And the question you should ask yourself is there a natural order to GPG P13R? Is there an order that everyone agrees upon from either smallest to largest, largest to smallest, worst to best, best to worst? Yes, there is an order, right? So it's actually in order already. So this would be ordinal. Part C, your social security number. It's a number, so it could be quantitative, but remember, to make sure, you should ask yourself, does this number count or measure something? And if that question doesn't help you, ask yourself the second question, which is, does it make sense to take the average? So if I have two social security numbers, does it make sense to take the average of those two numbers? Right? If I take the average of two social security numbers, do I get something that makes sense? No, right? If I take the average of two social security numbers, I could get a decimal, and a decimal is not a social security number anymore. So it doesn't make sense to take the average, which means it's going to be qualitative. Okay, if it's qualitative, we have to decide, is it nominal or ordinal? So is there a natural order to social security numbers? So this one I don't know. You could say that you can order it numerically, right, from smallest number to largest number, in which case I would say that yes, it's ordinal. But when we say ordinal, we mean an order that actually means something. So I don't know if social security numbers are given out in order. So is it true that the very last social security number corresponds to the very last person who was born? I don't think so. I think they might be given out in random order, but I'm not sure. So if they're given out in random order, I would say it's nominal. If they're given out in order of birth, or in order of, say, new citizen, I would say it is ordinal. So I'll accept both here. Could be ordinal. But I really think it's nominal. Part D, the amount of money in a jar of coins. Okay, so amount of money is going to be a number. Okay, so it could be quantitative. Okay, does this number count or measure something? Yeah, it counts how much money, right, or it measures how much money. So for sure, it's going to be quantitative. Now, quantitative, is it discrete or is it continuous? Question you should ask yourself is, can it be any decimal? So can the amount of money in a jar of coins be any decimal? If we're talking about money in a jar of coins, it's going to be something like this, right? $5.31. In other words, it's going to be a whole number and two decimals. That's it. Right? You're not going to get 5.3181978 as an answer. Right? So you can't have any decimal. So it's not going to be continuous. It's actually going to be discrete. This is similar to the shoe size example, right? Even though you can have decimals, you can't have any decimal. Right? So since you can't have any decimal, it's going to be discrete. Part E. This semester, I am taking statistics, biology, history, English. So statistics, biology, history, English, these are words. For sure, it's going to be qualitative. And qualitative is going to be either nominal or ordinal. Is there a natural order to these classes? No, there isn't. Okay, this is going to be nominal. Time you spend on YouTube. So time is going to be a number, right? We're talking about either hours, minutes. It's going to be a number. Does it count or measure something? Yeah, it counts how much time. This is going to be quantitative. and we have to decide whether it's discrete or continuous. Okay, question you should ask yourself is, when we're talking about time, does it make sense to have any decimal as a time? So does 2.351, does that make sense as a time? Yes, it does, right? So you could have any decimal as a time. It does make sense. So this would be continuous. All right, have a good one, and I will see you all in the next one.